Hey guys, welcome to class. It's Mrs. Brunk again, and today we're going to be looking at expressions and operations. And basically we're going to be reviewing the order of operations for evaluating expressions. We're also going to be looking at simplifying expressions by adding like terms. So I think I first remember my kids learning about the order of operations maybe in third or fourth grade. Possibly earlier than that. But I know that they learned them pretty early on because as soon as you start learning more than one operation, so learning more than just addition, like once you learn subtraction and multiplying and dividing, and you are going to be encountering expressions that have all these different operations. And if one person applies the operations in one order and another person applies them in a different order, and there's not some set rules for that, then we're going to get different outcomes. And so there's been this set of rules established for the order in which that we do certain operations. And you may have learned it at one time as PEMDAS. Sometimes you'll hear it as GEMDAS. So that's what we're going to focus on in the first part of this lesson is the order of operations. Now when we do operations with real numbers, and I mentioned this PEMDAS or GEMDAS, you may remember PEMDAS because they would use the P to represent parentheses, the E to represent exponents, the M for multiplication, the D for division, the A for addition, and the S for subtraction. Now, the reason why I prefer this GEMDAS was because I really like gems too, like diamonds and rubies and things. But really because grouping symbols is a really better explanation of the things that you do first, because there's lots of other things besides parentheses that group things together, like absolute value brackets, like square roots and things like that. Those would all be considered grouping symbols. So when we are simplifying expressions, we go straight to any grouping symbols, and we would evaluate anything inside those grouping symbols first. Now the second level, when we evaluate or simplify expressions, is to take care of any exponents and also roots. So the E represents exponents, but it also represents any roots. So if you have to take some square roots, cube roots, things like that, those would be equivalent to an exponent. And we'll learn more about why a root is just like an exponent later on. Now the next level is, they're kind of on an equivalent level, multiplication and division, the M and the D. And so because they are at the same level, when we do address multiplication and division, we work any multiplication and division from left to right. So how we prioritize multiplication or division is which one comes first as we read the expression from left to right. And the same goes for addition and subtraction. So at that final level, we would address any addition or subtraction moving in the expression from left to right. So let's go ahead and put those order of operations in practice. Number one, the first thing we're going to do is target any grouping symbols. So we're going to go right ahead to the parentheses there. We'll take a look at that. And so within the parentheses, there's also an exponent. So we'll go ahead and evaluate that first. So 2 to the third power means 2 multiplied by itself 3 times. That's 8. So the 11 minus 8 is 3. I'm going to go ahead and rewrite this. 29 minus 3 plus, I'm going to go ahead and evaluate this exponent because that would be the next level, the E for exponents, 6 squared, which is 36. Then this is a divided by sign, 4. So now we're at the next level, and so that means we need to take care of any multiplication and division from left to right. So there's this multiplication right here that we need to take care of. So taking care of that, 36 divided by 4 is 9. And so that leaves us with 29 minus 3 plus 9. And now that's all subtraction and addition, so we work from left to right. 29 minus 3 is 26, plus 9 is 35. And so our final answer is 35. Let's look at another example. Number 2, notice, has some absolute value. So that's why I like to use the GEMDAS because that reminds me there are other grouping symbols than parentheses. So I'm going to go ahead and evaluate that first. This set of absolute value means to take whatever is inside and make it positive or 0. So in other words, sort of just ignore if there is a negative sign. So the absolute value of -8 is 8. So if I rewrite that, that's going to make this 8. Taking care of the exponent next, 4 to the third. 4 raised to the third power is 64. So that's 64 minus the 8 that we had in the absolute value brackets. That's a multiplication sign, so times 6, and a divided by 16. So next we need to take care of any multiplication and division from left to right. So we're going to go ahead and evaluate this end part of the expression. So 8 times 6 is 48. So this would be 48 divided by 16. And 48 divided by 16 is 3. So that leaves us with 3 here. And then 64 minus 3 for our final value of 61. So I'm going to leave the next two to be you try questions. So I want you to go ahead and pause the video and give number 3 and 4 a try, and you can tune back in to check your final answer when you're done. So go ahead and pause the video now. Okay, so number 3, the value should have been 4. Oh, I'm sorry, that's, I think, -4. So -4, and number 4 is 7 1/4. Or you may have left it as an improper fraction of 58/8 or reduced to 29/4. Or maybe even as a decimal as 7.25. So one of the places where we most often find that the order of operations is very important is when we're evaluating expressions for given inputs for variables. So example 5 and 6 are really just an extension of what we're doing in the first 4 examples. We are dealing with variables, but we're given numeric values to substitute in for those, and then we have to follow the order of operations. So let's go ahead and take a look at number 5, and I'll leave number 6 as a you try. So with number 5, we're given some values to input for the variables A, B, and C. So let's go ahead and do that first. So I'm going to put in a 3 for the A. I'm going to put in a -4 for B. Now, one thing to keep in mind is when you substitute values in for variables, it's always a good idea to use parentheses if they're negative. So I went ahead and did that. And then the 8 for the C. And now I'm going to follow my order of operations. So my order of operations, and by the way, a fraction bar is like a grouping symbol, really, because it separates a numerator and a denominator. And so rather than thinking of it as a division, we think about it as a grouping symbol to group a numerator, everything in a numerator together and everything in a denominator together. So we'll go ahead and find out the numerator and then the denominator, and our final step will be to divide. So with a numerator, we have 3 times -4 squared. Well, -4 squared means -4 times itself, which is a positive 16. Times 3 would be 48. The denominator turns out to be 8 plus 12, which is 20. And so our final answer in simplest form would be to reduce 48/20, which reduces down to 12/5, because we can take a 4 out of the top and the bottom. And we could also turn that into a decimal. And as long as it's a finite decimal, that's fine to give a decimal answer. But if it's going to be something you have to round, or say maybe a repeating decimal, it's best to leave it as a fraction. In this case, it is a finite decimal, so either one of them is fine. So we're going to go ahead and leave number 6 as a you try question. So go ahead and pause the video and find the value of the expression given the 2 replacement values. Pause the video now. And if you found a value of 52, then you're in business. If not, be sure to bring those questions up when I see you in class. Let's go ahead and turn the page.